Have you ever had that moment, like maybe it's late at night, you're at the airport, you open up a ride-sharing app, and the price just makes your eyes water.
Oh, yeah. The surge pricing?
It's surging, it's expensive, and you think, okay, well, at least the driver is making a killing tonight. But then you talk to the driver, and you realize they're seeing, what, like barely half of that fare.
It's the universal friction of the modern gig economy. There's this
Yeah.
massive, massive gap between what you pay and what the actual worker receives.
Exactly. It feels like we're all paying this gatekeeper tax. Some giant corporate middleman sitting in the cloud, coordinating everything, and taking this huge cut just for introducing two people.
Right, and we've accepted it because, well, what's the alternative?
We can't go back to hailing cabs with our arms, right? We trade money for convenience and, I guess, for trust. We trust the platform to vet the driver, to handle the payment.
To make sure we don't get scammed.
But today, we are unpacking a source that claims we don't need that middleman anymore, or at least not the corporate kind. We're looking at a document called Technical Specification, the XRPL Hybrid Super App.
Hmm.
And I have to say, when I first saw that title, I thought, oh boy, here we go,
Yeah.
another crypto white paper promising to save the world. But this feels different.
It is different. This isn't a marketing pitch. It's not a slide deck for VCs. It's a real architectural blueprint, a nuts and bolts guide on how to build a system that merges, like an Uber with a Craigslist.
And the kicker is that it's all powered by a native cryptocurrency called RIDE, running on the XRPL EVM sidechain. Okay, hang on.
Yep.
Before we lose half our audience who just heard XRPL EVM sidechain and their eyes glazed over,
Yeah.
we need to unpack that. Why does that specific tech matter so much?
It's crucial. It tells you everything about the philosophy of the builders. They're not just trying to clone Uber. They're trying to rebuild the entire economic engine underneath it. The XRPL, that's the XRP ledger, it's famous in the crypto world for being incredibly fast and very, very cheap to use. We're talking fractions of a penny per transaction.
Which is pretty important if you're paying for a $10 car ride. You don't want a $5 transaction fee.
Exactly. But the XRP ledger on its own is a little limited. It's mostly for moving money. That's where the EVM sidechain part comes in.
Right.
EVM stands for Ethereum Virtual Machine. Think of it as like a universal translator for code. It lets developers write these complex programs, smart contracts that can handle logic. Logic like, if the car arrives at this spot, then release the funds.
So they're taking the brains of Ethereum, the smart contracts, and sort of grafting them onto the speed and low cost of XRP.
That is the goal. High IQ, low cost. And the ambition here is to create what they call a hybrid Web 2.5 architecture.
Okay.
They're proposing this proof of service model where drivers actually mine crypto just by driving, and a security system they call economic checkmate.
Economic checkmate. That sounds intense, like something a James Bond villain came up with.
It's actually a really elegant mathematical concept, but we'll get to that.
Okay, let's start with the architecture then. Hybrid Web 2.5. That really stood out to me because usually crypto projects are such purists, they want everything on the blockchain. So why advocate for a hybrid approach?
That is the million-dollar question, and frankly, it's where most of these projects fail. The problem is speed. Blockchains are incredible for security, for immutable records, but they are inherently slow.
Slow like, what do we talk? Dial-up internet slow.
Slower. I mean, imagine you're standing on a rainy street corner. You tap request ride. If that request has to be validated by a whole blockchain network, put into a block, you could be standing there for 30 seconds, maybe a minute.
Oh, no way. In the ride-sharing world, that's a death sentence. If the app lags, I'm closing it and opening the competitor.
Exactly. Milliseconds matter. So this blueprint proposes a solution with three distinct engines: the presentation layer, the speed layer, and the settlement layer.
Okay, let's break those down, because this feels like the secret sauce. The presentation layer, that's just the app on my phone, right?
Yep, built with React Native. But it does double duty. It's your UI, the maps, the buttons, all that. But it also acts as a non-custodial crypto wallet.
Non-custodial, meaning I hold my own keys, the company doesn't.
Correct. In an app like Uber, your credit card, your ride credits, they all sit in Uber's database. If they get hacked or they decide to ban you, you're out of luck. Here, you are in control of your funds at the device level.
Got it. Okay, now the speed layer. This is where the hybrid part really kicks in.
This is the really clever bit. They aren't throwing away traditional tech. They're using Node.js and PostgreSQL. These are standard, kind of boring, but incredibly fast database tools that run like 99% of the internet.
So they're using Web 2 tech, the old school stuff, to handle all the heavy lifting.
But only for the data. Things like real-time GPS matching, hosting the images of that used TV you want to buy, finding the nearest
So
driver.
all the stuff that needs to be instant.
All the stuff that needs to be instant happens on a centralized server.
Okay, so the data, the
Yeah.
maps, the photos, the location dots, that lives on the fast server.
Yeah.
But where does the value, the money, live?
That's the settlement layer. That is the XRPL EVM blockchain. That is where the money is, where the smart contracts live, where the immutable ledger is kept. The real insight here is separating data from value.
Data needs speed. Value needs security.
Exactly.
I'm trying to think of an analogy here. Okay, bear with me. It's kind of like a mullet.
A mullet.
Yeah, business in the front with the fast servers,
Yeah.
slick, responsive, consumer-friendly. Party in the back with the crypto security, decentralized, trustless. A little wild.
I have never heard it described as a software architecture mullet before, but
Right.
it actually kind of fits.
Okay.
Or to use a more dignified analogy, think of it like a library. The speed layer is the computer where you can instantly search for a book. But the settlement layer is the restricted archive in the basement where they keep the rare manuscripts.
Right, you don't need vault security to look up a title.
But you absolutely need it when you're moving the actual asset. The point is, to you, the user, it just feels like Uber. You don't even know you're using a blockchain until money actually moves.
So let's walk through a ride. I want to see how that handoff happens. I'm the rider. I open the app. I tap request ride.
Okay, step 1, matchmaking. This hits that speed layer. The Node.js server uses spatial database tools to find the nearest driver instantly. Boom, you're matched. No blockchain yet.
Okay, I'm matched. Now I need to pay, or at least promise to pay.
Right, this is where we cross into Web 3. Your app initiates what's called an escrow lock. You're not paying the driver directly. You're sending a transaction to the XRPL blockchain. Let's say the fare is 50 RIDE-IT tokens. Those tokens get locked into a smart contract.
So the money is sitting in this digital locker. The driver knows it's there. I can't take it back, but they can't touch it yet either.
Precisely. It creates a trustless environment. You don't need to trust the driver doesn't need to trust you. You both just trust the code. Then the ride happens. You get to your destination. Now we need verification.
Right, because if I just say, I'm here, how does the system know the ride actually happened?
It goes back to that hybrid model. The centralized server checks the GPS coordinates of your phone and the driver's phone. If they match the destination, the server generates a cryptographic signature. It's like a digital seal of approval.
And the driver takes that signature to the digital bank.
Effectively, yes. The driver's app submits that signature to the smart contract on the blockchain. The contract sees the valid signature, which proves the ride happened, and poof, it automatically releases the 50 ride tokens to the driver.
That's smooth. But here's where it gets really, really interesting. The mining twist. The driver isn't just getting the fare, they're getting something else.
This is my favorite part of this whole economic model. It's called proof of service.
Which sounds a whole lot like proof of work in Bitcoin.
It's a very clever play on that concept. In Bitcoin, mining means you have a warehouse full of computers burning insane amounts of electricity to solve, like, arbitrary math puzzles. That's how you earn new Bitcoin.
Right, it secures the network, but it doesn't really do anything useful for society. It's just heat and math.
Exactly. But in this super app, the work isn't solving puzzles, it's providing a service. When you drive someone to the airport, that is mining the block.
So by just doing my job, I'm literally minting cryptocurrency.
Yes. When that smart contract releases the fare, it also mints brand new tokens, let's say 10 RIDE tokens, as a mining reward. The driver is validating the network's utility just by being a productive worker.
That completely changes the incentive structure. You're not just a gig worker anymore. You're a network participant. You're earning equity in the system you're helping build.
And it solves the cold start problem. Why would a driver join a new app with no riders? Well, if they can earn crypto rewards just for being available, it subsidizes their income while the network grows.
I also saw a little detail in there for the eco-conscious folks. Drivers with EVs get a bonus.
They do. It's hard-coded into the mining logic. If the system detects you're driving an EV, you get a 1.05x mining bonus, so a 5% bump in your crypto rewards. It's a subtle nudge, but it aligns the platform's growth with sustainability.
So we have a ride-sharing system that mines crypto. But it's a super app. So it's also trying to take down peer-to-peer marketplaces.
Which is a huge undertaking. I mean, the trust problem in peer-to-peer commerce is massive. If I want to buy a used laptop from a stranger on Craigslist, I have to meet them in a coffee shop, hope the laptop works, hope they don't rob me.
Or you pay them on Venmo beforehand to hold the item, and then they just ghost you.
Exactly. This blueprint aims to replace all that messy human trust with code.
Okay, so let's walk through it. I want to sell my used TV. I post it for, say, $100.
You list it, photos, the description, that all goes to that fast Web2 database. But the pricing is unique. You list it in dollars for stability, but the payment happens in RIDE tokens.
But wait, if I list it for $100 and the value of the RIDE token is changing every second, how does the app know how many tokens to charge?
That requires a very cool piece of tech called a blockchain oracle.
Whoa, hold on. Oracle is another one of those mystical crypto terms. What is it actually doing?
Think of a blockchain like a computer that's buried in a secure bunker. It's super safe, but it has no internet connection. It doesn't know the weather, it doesn't know who won the Super Bowl, and it doesn't know the price of the US dollar.
Okay.
An oracle is a trusted data feed that bridges the outside world to that bunker.
So it basically whispers the price of the dollar into the bunker.
That's a great way to put it. So when the buyer clicks buy, the app queries the oracle. It says, hey, what's $100 worth in RIDE tokens right now? The oracle might say, that's 2,000 tokens.
Got it. So I'm the buyer. I agree to the price. I lock my 2,000 tokens, and they go into that same smart contract escrow thing.
Correct. The seller sees the funds are locked. They know the money is there. You can't run away with it, so they ship you the TV. But, and this is the crucial part, the funds are not released yet.
The seller doesn't get paid until I say so.
Until you tap that item received button in your app. That action is what triggers the smart contract to release the funds.
That sounds great for me, the buyer.
Yeah.
But I have to play devil's advocate. What if I get the TV and I just never tap item received? I keep the TV. Money stays locked forever.
The document implies there would be arbitration mechanisms, probably smart contract timeouts. So, for example, if the shipping tracking shows delivered and you don't file a complaint within, say, 3 days, the funds release automatically. It's just the default from trusting a stranger to trusting the contract.
Okay, sticking with the devil's advocate role, because I am that skeptical friend at the party, let's go back to the ride sharing. If I can mine tokens just by driving, what stops me from cheating?
Ah, the Sybil attack, the
Yeah.
classic crypto exploit.
Right. What if I put two phones in my car? One's the driver, one's the rider. I request a ride for myself, I drive around the block, I pay myself, and I collect the mining reward. I'm just printing free money.
This is the exact problem that killed so many of those early play-to-earn games. And the authors of the spec, they clearly saw it coming. They have an entire section on it, and they introduced that concept we mentioned earlier, the economic checkmate.
Okay, walk me through the checkmate. How do you stop my two-phone scam?
You don't stop it with rules or police. You stop it with math. You make it mathematically impossible to profit from the fraud.
Explain the equation.
Okay, every ride has a cost, right? There's the fare itself and there's the platform fee. Let's say it's 10%. Now, if you're faking a ride, you are paying the fare to yourself. So that's a wash. It goes from your left pocket to your right.
Okay, I'm breaking even so far.
But you have to pay that platform fee. That 10% is gone. It goes to the network. So if the fare was 50 tokens, you just paid a 5-token fee. Now you look at the mining reward. What if the mining reward is only, say, 2 or 3 tokens?
Then I've lost money. I paid 5 tokens in fees to earn 3 tokens in rewards.
Exactly. You are literally burning money every single time you try to scam the system.
So honesty is enforced by profitability.
Yeah.
It's not that you can't cheat, it's that you'd go broke doing it.
Precisely. The system is calibrated, so the cost of the fee is always just a little bit higher than the reward for a single trip. The only way to profit is to drive a real passenger who is paying the fare with their money.
That is incredibly clever. It uses the scammer's own greed against them.
It is. And just in case the math isn't enough, they have a layer 2 defense they call the identity firewall.
A backup.
Right. To run a massive scam, you'd need hundreds of fake accounts. The app would block this with strict device fingerprinting, 1 hardware ID per account, and SMS verification.
So the logistics of cheating are just as painful as the economics.
Exactly.
Let's talk about the business model then. We know how Uber makes money. They take a huge chunk of the fare, 30–40%. How does this super app sustain itself?
This is where the decentralized nature it really shines. Because they're building on the XRPL infrastructure, the document claims the operating costs are shockingly low. We're talking approximately $70 per month.
Wait, $70? With a 7? That is less than my phone bill.
That is the power of not having a massive corporate headquarters and thousands of middle managers and giant server farms. When you build on a public ledger, you're outsourcing your security and your uptime to the whole network. You don't have to pay for the servers that run the blockchain.
So their overhead just collapses, and that explains how they can have lower fees.
Right. They propose a 10% fee on rides and a 3% fee on marketplace sales.
Which is way lower than the industry standard. But I also saw something about the burn.
Yes, this is a key part of the tokenomics. They're actually burning tokens. Specifically, 1% of that marketplace fee is permanently destroyed, sent to a black hole wallet that nobody has the keys to.
Why on earth would you just destroy money? That seems counterintuitive.
To create deflation. Think about it. If the supply of ride tokens is constantly shrinking as the app gets used more and more, simple supply and demand suggests that the remaining tokens should, theoretically, become more valuable over time.
So if I'm a driver and I'm holding on to the tokens I mined last month, the fact that people are using the app today is actually helping increase the value of my savings.
That's the theory. It creates a positive feedback loop. It aligns the incentives of the platform, the workers, and the users. Everyone wants the ecosystem to thrive because everyone owns a piece of it. In the Uber model, only the shareholders really want the company to thrive. Here, the drivers are the shareholders.
This brings us to a sort of synthesis then. We started with a blueprint for an app, but it really feels like we're looking at a blueprint for a new kind of economy.
I think that's exactly the right way to frame it. This isn't just a piece of software. It's a self-sustaining economic engine. You have workers, the drivers, who are essentially part owners. You have infrastructure costs that are near zero. And you have trust that is enforced not by a manager in a suit, but by code and math.
It's just fascinating to see how all the pieces fit together. The hybrid approach solves the speed problem, proof of service solves the labor supply problem, and the economic checkmate that solves the fraud problem. It's a very complete picture.
It is, and it really challenges this assumption that we need these centralized giants to facilitate our daily lives. We've accepted that we need a big tech company to help us find a ride because we need someone to police the bad actors. This document says, no, you don't. You don't need a policeman. You just need the right architecture.
It's empowering, but also a little daunting. It puts a lot of faith in the code. If there's a bug in that smart contract, there's no customer support line to call.
That is the risk. Code is transparent, which is good, you can audit it, but it is also unforgiving. However, think about the alternative. We currently put an immense amount of faith in corporations that have shown time and again their priority is shareholder value, not user welfare. At least with code, the rules of the economic checkmate are visible to everyone.
That's a really strong point. Transparency is its own kind of security.
And that leads me to this question I've been mulling over since reading this.
What's that?
If we can design these systems where honesty is the only profitable option, where the math literally prevents fraud without human intervention, do we still need traditional managers or middlemen to enforce rules at all?
Whoa, that's a big one.
Think about it. We use managers to ensure quality, to prevent theft. But if the incentive structure does that for us, could this logic apply to things bigger than ride-sharing? Could we apply it to, I don't know, insurance, to voting systems?
A world where you can't cheat because it's simply too expensive to even try.
Exactly. It redefines the role of authority. We might be moving from a world of don't be evil, which was Google's old motto, right? To a world of can't be evil.
Can't be evil. I like that. It's a proactive morality just baked right into the system.
It's the ultimate promise of this kind of Web3 technology. Whether this specific super app succeeds or fails, and building a two-sided marketplace is incredibly hard, no matter the tech, the architectural pattern is here to stay. This hybrid Web 2.5 model is the bridge we've been waiting for.
It's the mullet of the future.
I am never going to unhear that announcement.
You're welcome. Well, there you have it, a deep dive into a technical spec that turned into a philosophy lesson on trust, economics, and mullets.
The best tech always does.
Absolutely. To our listener, the next time you hail a ride or you're scrolling through a marketplace, just take a second to think about the invisible machinery making it all happen and ask yourself, is there a better way?
There usually is.
Thanks for listening. We'll catch you on the next deep dive.